Now we want to think about the vector PQ cross PR. Now the cross product of two vectors is perpendicular to both of those vectors. It's only defined in three-dimensional space. And if we orient ourselves here, if we take PQ and cross it with PR, it's going to be perpendicular to both of those vectors, meaning, now we don't know how anything is oriented here, but this should be a right angle, the angle between the cross product and the PR vector, and also the angle between the cross product and the PQ vector. Both of these are going to be right angles, and the right-hand rule, which we'll talk about a little bit more later, PQ cross PR is off in this direction. So it's going to be in this direction as opposed to, let's say, the opposite direction, which would also be at a right angle to both of these vectors. Now, to calculate the cross product, PQ cross PR, we use a determinant. Okay, so getting ourselves centered here. And the determinant is going to be I, J, K for the first row. The second row will be the components of PQ, which are -3, 6, and 5. And the third row is going to consist of the coordinates -5, 6, and 7. Now this determinant is evaluated by minors. We eliminate the row and column of I, forming the determinant 6, 5, 6, 7. And then we subtract J times the minor we get if we eliminate the J row and column, and that determinant would be -3, 5, -5, 7. And then we add K times the determinant we get if we eliminate the row and column of K, and that's going to be -3, 6, -5, 6. Each of these smaller determinants is evaluated by subtracting the main diagonal. Diagonal goes in this direction, minus the diagonal in this direction. So that's going to be I times 6 times 7 is 42, minus 5 times 6, which is, I was going to write out 5 times 6, that's 30, etc.